Where we left off last was talking about the different models for convection. You don't need to know a whole lot about the different models as long as we understand the concept of convection and its role in plate tectonic movement. So different plate boundaries. We have divergent plate boundaries, convergent plate boundaries, and transform fault boundaries. These are different ways that plates are either colliding or they're spreading apart or they're just scratching against each other. So divergent is when they're going to be spreading apart, and we're going to have magma coming up between these two plates, constructively creating more layer of the lithosphere of the crust. Convergent boundaries is destructive. So we have two plates that are coming together. One is going down and is going to enter the asthenosphere. The other part is going to come on top of it. Continental oceanic boundaries, we see the continental plate go on top of the oceanic plate. And transform fault boundaries is what happens when they just slide against each other. They're not creating or destroying parts of the crust, but the transform fault boundaries is what we experience as earthquakes. So there is some activity going on at these boundaries. And here's a visual model for each of these. On the left, we have divergent boundaries. In the middle, we have convergent boundaries. And on the right-hand side, we have a transform fault boundary. Different types of convergent plate boundaries. The top one is oceanic to continental crust. Notice the oceanic crust is going under the continental crust. In the middle, we have oceanic. So we have oceanic crust going under another oceanic plate. It's going to create underwater volcanoes. Islands are formed because of these oceanic convergent boundaries. And then we have continental convergent boundary, where continental crust is going to collide with more continental crust, and this creates more complex mountain ranges. We don't see a lot of volcanic activity here simply because the crust is too thick for magma to make it all the way to the top. So magma is responsible for all of this plate tectonic movement. So why does magma exist? What causes the rock to get so hot that it's able to flow? The first part is just heat. The idea that as we go down, geothermal gradient means as we go farther down into the earth, there's a natural increasing in temperature that goes on. Part of it might be due to friction at subduction zones that produce heat. It might be because there's hotter mantle rocks can rise and intrude crustal rocks, but just the geothermal gradient, the fact that it heats up as we get closer to the center of the earth, is part of the reason for the formation of magma. Pressure, so melting involves an increase in volume. So as we get higher and higher pressures, we can go higher and higher temperatures. If all of a sudden pressure is taken away, that rock that is really hot now has the capability of melting and creating magma. And lastly, we have water. So if water is in rock, it lowers the melting point of that rock. So if there's any water in the rock, it's going to lower the melting point significantly. As you can see, there's a melting point decrease of 100 degrees Celsius for just 0.1% water content. Okay, so an intro to Earth's history. So we know these things based on different records of geological events and changing life forms. Uniformitarianism, you don't need to memorize that word. All it means is that the same rules that happen now happened in the past. So nothing has changed as far as how the Earth processes and structure has been happening since the formation of the Earth. Okay, and we're going to stop there and come back in the next one.